Hi class, today we're going to look at Cramer's rule, and we're going to solve the two equations because I've already given you some notes. So we're going to solve these equations using Cramer's rule. In Cramer's rule, we will start by getting the determinant. So the knowledge of determinants is very important because that is basically what we'll be using. So first of all, you need to write a matrix of this equation whereby we will be having 3, 4, 1, minus 6. And remember what we have said, we're going to get the determinant of the original equation as it is. So that one will be called B naught. The determinant of the original matrix, which will be given by this. And how do you get the determinant? You know, the determinant is given by the product of the right hand diagonal minus the product of the left hand diagonal, which will be given by 3 times minus 6 minus 1 times 4. And basically this gives us if you check, this is minus 18 minus 4, this gives us minus 22 as our original determinant. So therefore we can say, therefore our D naught is equal to minus 22. The second thing we will do, if you want to get X, you need to inject this part in this X position. So because we want to get dx, the determinant of the first side, which is x, so you need to substitute with this particular variable. So we will have it as 8, 10. We are substituting it on the side of x. Then we write 4, 6. 4, 6. And we get the determinant. So I've said if you want to get x, you have to substitute this here. If you want to get y, you will substitute this here. So let us get the determinant here. It will be given by right hand diagonal minus the left hand diagonal, which will be given by 8 times 6 minus 10 times 4. Remember, this is the same as 48 minus 40, which gives us 8. We can say therefore our D naught, our dx is equal to 8. That is our first point. We can now move to get dy. And I've said clearly that if you want to get y, then you need to take this part and substitute here in place of y. So we shall have it. Our original equation was 4, 3, 1, 4, 6. This was for x, this was for y. Because we want to get the determinant of y, then we will substitute this part with this one. So you will have 3, 1. Then instead of 4, 6, we shall have 8, 10. This will be equals to, the determinant will be 3 times 10 minus 8 times 1. If you do this math, you will get 30 minus 8, which gives us 22. So we can say therefore dy is equals to 22, positive 22. So you can see our D naught, which is the original determinant of the original equation, is minus 22. The second determinant, which is dx, is equal to dx. We are talking about these. These are very crucial. These determinants are very crucial because, like I told you, this method involves using a lot of determinants. So basically, if you need to get your x, our x will be given by d naught by dx all over d naught. That is how we will get our x. You take the dx divided by the original determinant. So we can say our dx will be equal to our x will be equal to dx over d naught, which is equals to our dx, like we have indicated, was 8. That is our d naught. You can see we having we did some mistake here that we need to correct. Remember, this was minus 6, so that if it is minus 6, then this becomes minus 6. If this is minus 6, then this minus 48, minus 48 minus 40, this one becomes minus 88. So that is a correction that we need to take, so that now our dx is minus 88. It's very important for us to note that mistake that we made as we were fitting in those particular values. So like I said, you are taking your dx is minus 88, you divide by d naught. Our d naught is here, which is minus 22. So therefore our x will be equal to 4. If you divide this by this, you will get 4. So we have ascertained that the value of x is given by 4. If you need to get the value of y, you need to get your y. Y will be equal to dy divided by d naught. Our dy is 22. Then you will divide by d naught, which is minus 22. So therefore, our y will be equal to minus 1. You can see if you divide, you will get minus 1. So these are the values of x and the values of x and y. And if you substitute back in this equation, you will be able to see that actually it gives you the correct values. So this is Cramer's rule, and is very highly tested in NEC exams. So make sure you get all these concepts right, because you need them during the exam. So I need us to do this one last question, the second question, so that we can stop there. That was our first question. We can look at our second question, which reads, we having 2x plus 3y is equal to 7, and the other one is 3x plus 5y is equals to 9. Like I said, you need to determine the original determinant of this particular set of equations. So our determinant d naught will be equal to 2, 3, 3, 5. And it's very important for you to know the straight line represents determining the determinant. If you put the squared brackets, they just mean a matrix. But the moment you draw the straight lines, basically it is a command to get the determinant of what is inside those straight lines. So make sure you draw the right brackets that are required. So if you determine the determinant of this, the determinant will be equal to, we have said, the product of the right hand diagonal 5 times 2 minus 3 times 3. This gives us 10 minus 9. Of course, this is 1. So that we can say, therefore, our d naught is equals to 1. Because we're having 3x, that is 2, 3, 3, 5. So 2 times 5 is 10. 3 times 3 is 9. So the determinant is 1. We move to dx. Dx will be given by, remember now, we are substituting this one, the 7, 9 in this particular point. We have 7, 9, then 3, 5. The determinant here will be right hand diagonal 7 times 5 minus 3 times 9. If you take the difference, you will get this is 35 minus 27. 35 minus 27, you will get it as 8. Because if you take 8 here, of course you will get 1535. So the difference gives you 8. So therefore we can say our dx is equals to 8. We move to dy. Our dy, remember what we are now taking this one and substituting it in the second column, so that we can have 2, 3. You substitute 7, 9. If you substitute this, you will get right hand diagonal 2 times 9 minus 3 times 7. This should give you 18 minus, if you take the difference, this is minus 21. Remember now this one gives you minus 3. Gives you minus 3. So the second determinant, so therefore we can say our dy is equals to minus 3. Like we earlier said, that the value of x will be given by dx all over d naught. Remember our dx, this is our d naught, this is our dx, and this is our dy. So our dx is, remember our dx is 8 divided by 1. Therefore, our x is equals to 8. We can move to y. We have said y is equal to dy divided by d naught, which is, our dy is minus 3. So we take minus 3 divided by 1. Therefore, y is equal to minus 3. So those are the values of the equation that we were given. Remember, we were doing this equation. So the value of x is 8 and the value of y is negative 3. If you substitute, for instance, if you take 8 here, it will be 16. You bring this, it will be minus 9. So 16 minus 9 should give you 7. So that is those are the correct solutions for that particular equation. And we are going to stop there for now.